In the dazzling frontier of regenerative medicine, where scientists are using printers not for paper, but for living tissue, the search for the perfect bioink has taken an unexpected turn through the dairy aisle. That's right, milk and yogurt-derived polymers and vesicles are now being explored as components of 3D bioprinting materials with surprising promise. It's a scenario where the same molecular tools that give your yogurt its creamy texture might soon help build functioning liver lobules or cardiac patches. Who knew dairy had such ambition? At the heart of this innovation is the quest for a bioink that is both structurally supportive and biologically nurturing. Traditional bioinks often rely on synthetic hydrogels like polyethylene glycol, PEG, or natural ones like alginate and collagen. But milk proteins, especially casein and whey, have shown remarkable potential as biocompatible, gel-forming materials with tunable mechanical properties, ideal for constructing the soft, hydrated matrices that cells love to call home. Casein, a phosphoprotein abundant in milk and yogurt, has a unique structure that allows it to form micelles and gel networks under specific conditions. This ability to self-assemble and cross-link makes it a compelling scaffold material. When combined with other biopolymers or exposed to mild enzymatic or pH triggers, casein can create hydrogels with excellent elasticity, water retention, and cell adhesion, critical features for any matrix that aims to mimic real human tissue. Meanwhile, extracellular vesicles, EVs, derived from probiotic yogurt cultures, like lactobacillus-sourced nanoscale lipid bubbles, are gaining traction as bioactive enhancers. These vesicles naturally carry signaling molecules such as peptides, RNAs, and lipids, and they can be integrated into dairy-based hydrogels to turn a passive scaffold into an active signaling platform. In early experiments, these EVs have been shown to modulate inflammation, promote cell proliferation, and even direct stem cell differentiation, all without triggering an immune response. It's not just structural support, it's bioinstruction. Together, the casein-based hydrogels and yogurt-derived EVs offer a fascinating dual benefit, structural and functional. In 3D bioprinting applications, this combination could lead to constructs that not only hold their shape under the pressure of extrusion and layering but also actively promote vascularization, tissue integration, and cell survival once implanted. For organs like the liver or kidney, where metabolic activity and immune modulation are crucial, these bioactive scaffolds could be game changers. And the advantages don't stop at cell biology. Dairy-derived components are abundant, low-cost, food-grade, and widely available, which gives them a sustainability and scalability edge over rarer or more ethically fraught materials like animal-derived collagen or matrigel, which, fun fact, is made from mouse tumors. With dairy proteins, you get consistency, safety, and minimal pathogen risk, a key consideration for anything headed toward clinical trials or FDA approval. Researchers are already testing blends of casein with alginate, chitosan, or gelatin to tweak the mechanical and rheological properties for various tissue types. By adjusting the protein concentration, cross-linking density, or even the probiotic strain used for EV harvesting, scientists can customize these dairy hydrogels for specific applications, be it soft cardiac patches, nerve conduits, or layered skin grafts. There are challenges, of course. The natural variability of milk-derived proteins and the fragility of EVs under certain processing conditions mean standardization and stability remain key hurdles. Controlling degradation rate is another critical point. You want a hydrogel to support tissue formation, then gradually dissolve, not vanish mid-surgery or hang around like expired mozzarella. But the trajectory is clear. As bioprinting moves toward functional, vascularized, transplant-ready organs, the need for smarter, softer, and more dynamic bioinks is growing. And in this biotech landscape, dairy isn't just comfort food, it's structural biology. It's regenerative chemistry. It's a medium where milk and microbes can become the architects of healing. So, in the not-so-distant future, your 3D printed kidney might contain more than just lab-grown cells and synthetic gels. It might be built, in part, from molecules once destined for yogurt cups, reimagined, restructured, and repurposed for one of the most complex tasks in medicine, giving form and function to human life, one printed layer at a time.